So here's a you try example 11 for an airplane traveling. So we did this problem here. And we need to draw a couple of pictures first. Let me do this on the side. So we are given an airplane traveling at a speed of 450 miles per hour. So I know right away that that's going to be 450. That's our magnitude. With a bearing of 300 degrees. So remember with air navigation, 300 degrees is clockwise from the north. So this is actually 300 degrees. So what we want to find is the directional angle here. So we can find that. We can do 300 minus 270, and that'll get us this angle here. Then we could subtract 180. I'm sure whatever way that you can figure out how to solve that is totally fine. So I know this is 30 degrees, so that's our reference angle. That's kind of nice to know. And then the direction angle, therefore, would be 180 minus 30, which is 150 degrees. So 450, and then theta is 150 degrees for, let's call that V1. Now the wind is the other thing we need to factor in. It encounters a wind with a velocity of 40 miles per hour in the direction of north 30 degrees east. So north, this is 30 degrees, so that's north 30 degrees east. And then again, we really want our directional angle. So the directional angle is going to be 90 minus 30, which is 60 degrees. Then we know that that magnitude is 40. Okay, so we have 40, we have theta is 60 degrees, and so that hopefully helps you out a little bit more in this problem. So we're going to write both of these vectors. Let's start with V1. So V1 is going to be the magnitude. So that's 450 times cosine of 150 degrees I, that's I, plus 450 times sine of 150 degrees J, so that is V1. Then V2 is our wind, and so that was the magnitude of 40 times cosine of 60 degrees I plus 40 times sine of 60 degrees J. So let's simplify this. So let's work with V1. So cosine of 150 degrees, we know that is 30 degrees. So this is going to be 450 times root 3 over 2I plus 450 times sine of 150, that is a half. Now, I'm sorry, this should be a negative root 3 over 2 because we're on the x-axis here. Then for the V2, that is 40 cosine of 60 degrees, that is a half J, and then sine of 60 degrees is root 3 over 2J. Oh, it would help if I can read my own writing. This is supposed to be I. Okay, so now we need to add these two vectors together. So V1 plus V2, and so when you add that together, let's write it as negative 225 root 3, right? So half of 450 is 225, plus 20, I, this is I, that's our horizontal component, and then this is 250 plus 20 root 3, and that's our J, or 225, I apologize, 225. And then when you plug it all in your calculator, you will get negative 369.71 and 259.64. Now we need to find the velocity. And so that is going to be negative 369.71 squared plus 259.64 squared. And so that is going to be approximately 451.8 miles per hour. Now we need to find the true direction. So remember, we're going to have to take tangent of theta. Tangent of theta is b over a, so b over a, so that's 259.64 over negative 369.71. And so you will find that theta is approximately 35.08 degrees. Okay, and so we really want to find, let's find the directional angle. The directional angle is going to be 180 minus the 35.08 degrees, and so that is about 144.92 degrees. Now the true direction is we are going to take 270 degrees plus that 35.08 degrees, and so you will find that that is 305.1 degrees.